All right. So basically, before that, Aisha, have you done with the exercises? Exercise 1A, 1B, and exercise.
Not yet. Sorry. I was gonna catch up with it this week after my
Because the
submission.
submission. When is your
Yeah.
submission?
I have a submission today for theories, and then I have submission on Sunday and Monday and Tuesday. Yeah.
Sunday, Monday, and Tuesday.
Yeah.
What submission on Sunday?
Sunday is studio, the site analysis. Monday is also studio but individual, and Tuesday is for building structures.
Oh, okay. Sorry.
Yeah.
All right. Okay. So, like I mentioned earlier, basically, I mean, I don't mind if you need extension or anything, right? So please just let me know lah, if you need more time to do it. So this morning, Melissa already showed me the exercises, and I've commented. I hope you can improve lah based on my comment, right, Melissa? Okay, so today basically is going to be very short. It's on 3D shape grammar. It is actually similar. The process is actually similar to the 2D shapes. Okay, so it's the same thing. It's just that you replace 2D shapes with 3D objects. Okay, so previously square shapes, rectangular shape, triangle, and so on. So in 3D shape grammar, basically you use 3D objects like cubes, cuboid, and so on. Okay. All right. So as I mentioned, it's a similar with 2D. Right? So the 3D shape rules are similar with 2D shape rules, but in 3D form. So examples of rules are shown below. Right. So basically, if you have cube, so the one on the left, as you know, is the object before the transformation or before you apply the rules, and then the one on the right of the arrow is basically how you want the object to be transformed. So either by adding another shape similar to the original object, or it can be a different different object from the original shape or form. Okay, so if you still remember last 2 weeks, I gave a lecture on addition rule application, where basically you can also have addition and subtraction rules. So most of the time we are using addition rules, where you keep adding objects to the previous design development. But in some rules, basically you can subtract the objects from the previous development kit. But as I mentioned in the previous lecture, you can't do that with a single rule shape grammar. So you need at least 2 rules in order for you to apply the subtraction rules. Okay, so let's look at the examples of shape rules using 3D form. Okay, first one is the cubes, and then the second one is a box. Right, it's not a cube, so it's a square box, and basically you add another similar box to once you rotate, and then you attach to one side of the original box. Okay, and then the third one, where you use different object, you add different object to the original one. Okay, but I believe I've already mentioned this earlier also. If you want to add a different object, okay, in this case a smaller rectangular box, you want to add to the original object. So you also need to have at least more than at least 2 rules. So the first rules perhaps dealing with the flat box, right? And then the second rules would be basically this one, or maybe you need to have three rules. So the third rules perhaps dealing with the long box, okay, something like that. And then the fourth example basically is also a long box where you add a similar object, and then you rotate 90 degrees, and then you add to the bottom of the to the end of the original box. Okay, so if you look at the shape grammar, so the application of the rules in the development of design, right? So we take the first example of shape rules. So you can see that this one is very straightforward. Okay, so you just add a similar object to the side of the original box. So so those are the possibilities that you will get, right? So as I mentioned in the previous lecture, you can apply the rules to any side of the box. Okay, in this case, let's say this is you put the A here. Okay, so you add the object here. But if you look at the box in a different direction, okay, from a different angle, let's say here, you look at it this way. So the box still looks the same, right? So the position, the orientation of the box still looks the same, but now you imagine that you look at it from a different angle. Okay, so if A is like this, then you put the box here. But if A is like that, then you put the box. When you apply the rules, basically the box is going to be there, right? And then if you continue, you can also look at it upside down. So if A is like that, then when you apply the rules, the box is going to be down here, right? And then if you look at it from here, A, right? Then when you apply the rules, the box is going to be there, right? So I hope you can understand this concept because this is very important. You can apply the rules on the same object again and again by looking at the object from different angle, from different orientation, but the original object still the same. Okay, so the position, the orientation, there's no rotation, so the position of the object still the same. It's just that you look at it from a different angle. Okay, so let's say if you look here, A upside down, but then from that side. So when you apply the rules, basically the box is going to be here, right? So this is very important that you understand. Okay, because Melissa, when I look at your exercises that you did, right, it seems that you still haven't got it yet, no? Right? So you cannot simply.
Okay.
So because this rule is quite straightforward, lah. So maybe it's not that hard. But then if you have something like let's say your rules is like this, like what Melissa did, right? You do something like this. Okay, so let's say that's the rule. Okay, so you need to apply the rule one by one. So during the development, you apply first. You apply here, and then you apply to this object. Maybe you add another one here, and then you apply to this object. You add another one here. Then you look at it from different angle. Now you look at it from this angle. So originally you look at it from this angle. So that's how you get this. But if you look at it from this angle, you apply the rules, then the object will be here. And then
Okay.
you keep looking at the object from this angle, so you keep applying to this side. And then if you look at it from this angle, then when you apply, you get that. So the object will be there. So in this case, there won't be any possibility that you can get this kind of combination. You cannot simply mirror, because this is actually contradicting with the rules. So the rules not like that, right? So you cannot simply mirror the object and then only you apply the rules to the other side. So it doesn't work that way. So basically, in the design development process, all the shapes, the new shape should be applied one by one. Okay, so you cannot just simply finish one side and then you mirror everything to the other side, right? So I
Okay.
hope you can understand that. Okay, so this one is this is another example of shape rules. So basically, this one was produced by myself using 3D Max script. It's a computer programming language for 3D Max, right? So, I believe you know 3D Max. So instead of using the interface where you create a box or shapes, right, in 3D Max. So when I did this shape grammar, basically I typed the command on the command box. There's a command box at the bottom of 3D Max window. So I typed all the commands there to create this shape grammar. So basically the rules is to add another similar shape, but in 90-degree angle or in a perpendicular angle to the original one. So let's say the orientation is like this. Imagine the orientation is like this. Then that's where the object would be. But if you look at the object from a different angle, let's say you look at it from this angle, then when you apply the rules, the object is going to be here, okay, on that side. So if you look at it from this angle, sorry, okay, this angle, then when you apply the rules, the new object is going to be created here, right? Something like that. Okay, so basically this exercise using 3D Max script. Okay, so I type all the commands now, including the sizes of the box. Okay, so the sizes of the box, everything, and then when I hit the enter button, so basically the computer automatically generates this design, right? So basically that's how we use shape grammar nowadays, right? So you're basically using computer application rather than drawing or using manual application. Okay, so the first design is like this, right? So this is basically applying the rules 2 times to the original object. So I only get this side and this side. Okay, and here first the rule is applied to this object, and then you get this. I get this. Then apply the rule to this object. I get this. Okay, and then actually there's another object at the back, but you cannot see from here. So that's how the shape becomes like that, right? Right. So basically all these designs are following the rules, so including this one. So the first application is on here on this object, then you get this, and then apply the rule to this object, you get this, apply the rule to this object, get this, and until here. Right. So basically just keep repeating the operation, right? And this is another exercise that I did using 3D Max script. Okay, the rules is basically adding a similar object, again perpendicular in perpendicular angle, object, and then to be added at one near the shorter side of the box. So when you apply the rules, so let's look at this one. So this is the original object. So when I apply the first time, I get this, right? And then apply the second time, but now at this side. Okay, from this side, apply the rules, then the new object is okay. So that's how I got this. And then when I look at the object from upside down, basically it's on the other side lah. You just imagine that this object is a transparent object. So basically I applied the rules to this side, and then the orientation is like that. Okay, the side and the back there, and then when I apply the rules, that's how I got this here. And then apply again the rules, but this time to this side. Okay, on the other side. That's how I got this. Right. So again, so only single rules are applied to produce all these designs. Right. So in a way, you can see the similarities of the designs generated from the rules. Right. There are some similarities, but they are different. Similarities in terms of all the connected objects are perpendicular to one another. Right. You don't see any part of the design which suddenly you got something like suddenly it appears in the middle of the previous object, right? Because this is not following the rules already. Okay, or you won't see any anywhere in the design suddenly you got something like this, right? So because it's contradicting with the rules basically. All right, so next one is another example. This is not done by me, but as I mentioned earlier, basically instead of using drawings, using AutoCAD or using 3D software to produce, so you can actually use physical models to which is something like this. Okay, so the rule is quite simple. So basically you just overlap the same object to the previous one, but for this kind of rule, basically you need to know when you overlap, right? Or any other rules which involves certain angles. So you need to know what. Say this is the original object, and then you overlap. Oh, sorry, it's wrong direction. Doesn't matter. Okay, so you overlap with another shape. So you need to know how much. What's the angle here? Right? Is it 30 degrees or something like that? Okay, because when you want to apply to your design, you need to use the same angle. You cannot simply first this is 30 degrees and then suddenly you want to use a different angle 45, 50, so it doesn't work that way. So if the rule specifies, let's say this is 30 degrees, then every time you apply the rule to the object, it should be 30 degrees. So another important thing is the position of the rotation point. I would say this is a rotation point. Is it right in the middle, or maybe in at a quarter of the object? So, but I think it's easier if you put it right in the middle, something like this. So basically, in this developed design, it just applied, right, the same rules again and again, but to a different side of the object. So first, you look at it from here. then that's how you overlap that part. Or when you look at it from here, so when you apply the rules, basically the object is going to be created on that side, okay, but still 30 degrees, okay. And then if you look at it from upside down or from below, then the object is going to be created in a different place, right? Okay, so now let's try to understand more deeply on the symmetry group. Okay, so basically it's the same as last time. I already mentioned that about the triangle, right? Symmetry group is basically something like so I think I just write just read it here. A symmetric group of an object is a set of transformation on the object that causes it to look exactly the same as its original state in terms of position, size, and orientation. So last time during the 2D shape rules and shape grammar, I gave examples of this equilateral triangle. So if you look at it from this, the same. If you look at it from this angle, it still looks the same, but now basically the orientation is different, right? But if you remove the letter A, it is still look the same as this one, right? And then you can also look at it from this. It still look the same, but if you remove the letter. So these letters are important, or you can also use label, right? So these labels and this for you to understand where would you apply the rules, right? So the rule is like this. Okay, if the A orientation is like that, then you apply the rule on that side. Okay, so if you look at it from that side, that angle, so the object is going to be created here. If you look at it from this angle, then the object is going to be created here. If you look at it from this angle, the object is going to be created here, right? So it influences the position of the new object, right? So when you apply the rules, the different orientation of the original object determines where the new object is going to be created, right? So that's important for you because to understand, because that's what creates the design, right? So for 3D object, basically you have more possibilities when you apply this when you apply the rules, especially if the objects has sides, right? So for this rectangular box here, let's say it is not I mean the side, okay, the sides of the rectangular box is not as big as I mean the size is not the same of as the surface on the top surface, okay. So basically this is like a flat box. So the possibility of you looking at this object is a bit limited, but let's look at the labels. So you can label, or can also show you the letter, like if you put the letter on top of the object. So if you look at it, okay, if you look at it this way, or if you want to refer to the label, you can look at it this way. So another possibility, you can look at it this way. But overall, the box still looks the same. If you remove the label, if you remove the letter, the box still looks the same, right? And then imagine that if the box is transparent, basically now the label is actually at the bottom of this box, and the letter A is actually at the bottom, right? It is still look the same, but actually you are looking at it from a different angle. And then here also at the bottom, but now you look at the letter from that angle. Okay, so basically for all these four orientation of letters and labels, right? You won't change the state or the position or the size of the of this object of this original object. Okay, similar to this this example, right? Okay, now let's look at the more complicated one, right? So the earlier example, you only have two sides, two surfaces which are similar, right? So the top one and the bottom. Okay, but here in this rule, basically you have 1, 2, 3, 4, 4 sides which are similar to each other, right? So meaning that there are more possibilities that more angle that you can look at the object from. Okay, so first, let's say the A is in front, right? So that's how you're going to apply the rules. You're going to add the shape, okay, like this. But if you look at it from this angle, so A is on the side. If you apply the rules, that's where the new object is going to be created. If you look at it from that point, meaning that the A is actually behind, so when you apply the rule, the new object is going to be created here. And then if you look at the object from this angle, so A is on the side, when you apply the rules, that's where the new object is going to be created. Okay, but that's not all. You can also look at it from upside down angle. Okay, so now instead of looking at the A like this, so you imagine that the A position is like that. You apply the rules. That's where it's going to be. And then if you apply the rules to this side, that's how the new object should be connected. And then if you look at it from behind, so that's the position of the new object. And if you look at it from front, okay, but upside down, so that's where the new object is going to be created. So if you look at all these possibilities, basically they are all following the rules. Okay. Unless, but for this rule, there's no way suddenly the connection, as I mentioned earlier, is going to be like that. Then this is definitely wrong. Okay, so because it's not following the rules. All right, so this is an example of a rule application, right? Using a different object. So the original object is the flat box like this, and then the rule specifies that you need to add a long box on top of. Just look at the label where you are going to connect the box. Right. So in this case, basically, the end of this long box is going to be connected to the corner. Right? To this corner, the corner of the long box is going to be connected to the corner of the flat box. Right. So if you look at the symmetric group of the original object, so you can imagine, you can first you can look at it from this angle, and you can look at it from upside down, or you can look at it from this angle, and you can look at it from below, right? Which, when you apply the rules, the new object will be created at a different position. Okay, so the first one, this is the result of this. This is A, right? Results for A. This is the results for B. When you apply the rules, that's where it's going to be added. This is the results for C. This is the results for D. This is C. This is D. Right. But as I mentioned, basically, if you use two different shapes, two different objects, you need more than one rules. Okay, because if not, then just imagine if you only have this one rule. So when you apply the rules, first you apply to this angle, and then you apply to that angle, and then you apply to this angle. Okay, and then another one is so that angle. So that's it. That's the most you can do, because you cannot simply from the long box suddenly you want to add the flat box again. It doesn't work that way, because as if you still remember, I mentioned last time, the rules doesn't apply backwards. So meaning that if you see, even though the rules is here, you can see the object here, but basically when you apply the rules, you don't look at the objects on the right side. You look at the object from on the left side. So you cannot apply the rules to this object. Okay, you can only apply the rules to this object. Right? So that's why when you have this long box here, you cannot simply apply the rules to add back the flat box. It doesn't work that way. So that's why I mentioned, at least if you have two different objects, you also need to have another rules that concerns with the other shape. In this case, the long box here. So maybe when you have the long box here, how you want it to connect to the flat box, then you decide. So maybe let's say you want to add I know, so maybe right in the middle. Then in this case, okay, so you can add the so you apply the rules to that box. Okay, so now you apply the rules to this box. You apply the second rules, right? And then you can add here, and maybe you can add here as well. Okay, and then now you have this shape again. You can apply back rule number 1, where you add the object here. So you can continue with developing the design, right? Okay, so this is another example, but in this case, the object, the additional object, is basically the same as the original object, right? This is flat box. Okay, so it's similar. The concept of symmetry group is similar, right? So if you look at it from this angle, right? So the next object, sorry, basically, first you can actually ignore this, right? This symbol is actually to show how this design was created, right? So basically, first you apply the rules to this box, and then next you apply the rule to this box, but with that orientation. So you keep applying that. So basically, when you generate the design, so you keep adding the box on top of one another at the same. There's like one rotation, so you can see from here. So first here, second here, third here, fourth here, fifth, sixth, 7, 8. Right. So basically, there's some kind of rotation, consistent rotation. It's actually rotating clockwise. Right. So in this case, the next object is connected like this. The A is at that position. So when you apply the rules, first is like this, and then second is like this, and then third is like that. Okay, so fourth is like this. Right. So there's I think it's a spiral up, something like that. Okay, so you can try to understand that later. And then if you apply the rules like this, meaning that each subsequent object that you added, you are going to apply the rules at that based on that label. Right? So first like this is the original object. First you apply to the top. Okay, apply, you add here, and then if you So when you apply to this, you will add the new object below here, right? So it continuously goes on like that, right, to create a design. That's how you control the design development lah. So that's how you can control design development, where you can decide to have the to apply the rules in a similar manner, similar way from the previous object. Okay, so it is not too random, right? Because if it's too random, then probably the design that you create using the rules are not that interesting. Okay, you have some control how you want the new object to be added to the previous one. Okay, in this case, basically, yeah, so I think this is just an example, right? So if you apply the rules like this, and then this is the additional object, but if you apply the rules based on that label, right? Basically, you're going to create the new object is going to be created at the same position as the original object, right? So if you apply the rules at that point, right? So you will create another object at the same position of the original of the initial shape. No? So there's no point doing that, right? So you need to apply it to a different position, different label. So if you put the label at different position, then that's fine. Okay, but in this case, actually that object is similar to this one, right? Okay, but if you look at it from, you cannot look at the object from this angle, meaning that you put the label here. Okay, so that's already different, because basically you're already mirroring the object, right? Even though if you mirror, it's still at the same position, but basically you are moving the object. Not moving lah, it's mirror, it's something a bit weird lah. But so so my advice to you is not to mirror lah. So if let's say the origin label is here, so okay, I think it's easier to understand like this. So yes, if I put A, if you mirror, it still looks like A, right? But if I put B, okay, assuming if you put the label at that side, then now the B becomes like this. Oh, still looks the same. Sorry about that. I think C lah. Maybe what letter? F. I think F would be, or G lah. G would be better. Right? If I use C, then it looks like C also lah, right? If I use A, I mirror, it still looks like A. If I use B, if I mirror, it still looks like B, but in a different orientation. If I use C, then if I mirror, it still looks like C, but in different orientation. So I think G is a good example. G or F, F or G. So G. So if you imagine, if you change the label to that like this, right? So that's not G anymore, right? So it's already different. So that's why you cannot apply the rules in that manner, right? Because it's actually different. So if the rule is like this, if let's say the rule is like that, you add the object here. This is G. But if the G is like that, if you apply the rules, it goes to that side, which is actually contradicting with the rules itself, right? So I hope you understand that. Okay, transformation of shape. Basically, I've shown this in 2D rules as well, but there are more variety in 2D rules, how you can transform the shape. Basically, it's not really a transform. I mean, this transformation is basically how you move, especially if you want to add new object. So how you want to create, how you're going to add the new object to the initial object. Okay, so basically, you can move it to the back, to the top, or any direction you want. Right. It can be touching, or it cannot be. It also can be separated. Right. Doesn't matter. Okay, similar to the object, so you can also rotate. Right. You can rotate at, or the rotation point is, rotation axis is on one side, on edge of the object, or it can be away from the object. Okay, and then screw rotation, basically you rotate and then you move. You rotate and you translate. There's rotation and translation happening. Okay, so you rotate first and then you move. You shift the object to a certain position. And then reflection. Okay. So you want to reflect in 2D shape grammar, 2D rules. Reflection is something like this. So if you use triangle, so you reflect that triangle, get to that position. All right. Light reflection. Basically, you reflect here. First you reflect and then you move to another position, right? And here roto reflection. Basically, you reflect and then you rotate. Scale, right? I think this is quite straightforward. Either you scale up. Let's say the blue color is original object, and then sorry, the red color is the original object, and then you scale down. The blue color is the new object. And then or you can scale up. So let's say the red color is the original object, and then you scale up to the blue outline box. Right. But in similar to the other transformation, okay, so when you transform, you really need to decide. For example, like this one, translation, movement, right? Basically movement. So how many centimeter or how many mm that you want to move? So there should be a consistent dimension. So let's say 10 mm. You move 10 mm. Then for when you develop the design, so along the way, so all the movement should be 10 mm, right? So here also same movement 10 mm, something like that. But this one involves some angles. You move to a certain angle. So if you involve angle, then you need to decide. So what is this angle? Is it 30 degrees? And how long or how far from this object? So maybe 10 mm as well. So all that need to be decided. So similar to this one, rotation. If you use rotation to transform, you need to decide whether what's the angle that you want to use. So is it 90 degrees? Okay, this is also 90 degrees. Or you can rotate at 30 degrees, so it doesn't matter. Okay, and then here also same rotation. You need to know the angle, and translation you need to decide where you want to move. In this case, you just move the corner from this corner to that corner, right? So that could be the reference. And then mirror. So mirror also you need to have the dimension. So let's say how far from this mirror, the mirror should be from the original object, right? And then when you mirror to this side, So basically, you are going to add another similar dimension. So this is 10 cm. So this is also 10 cm if you mirror. Okay, similar to this and this. So for case, if you use manual drawing, it's difficult for you to use scale. But if you use AutoCAD or you use SketchUp or 3D Max, it's quite easy. So you need to decide on the scale factor. So if you want to scale down, then the scale factor will be, let's say, scale down by 0.7 scale factor. 0.7 times. So meaning that it's going to be smaller than the original object. But if the scale factor is, let's say, 2 or bigger, more than 1, then it need to be scaled up. It can be 2, it can be 2.5, okay, it can even be 1.5. So it decide on that scale factor. And if you're familiar with AutoCAD, then you know, when you want to do the scale factor, basically it prompts you to decide on the reference point or something like that. So in this case, the reference point is here. So when you scale up, you scale down, it will be based on that corner. Okay, so that corner would fix there. Okay. I think in 3D Max and SketchUp also the same. Okay, basically that's all for today's lecture. Actually, there's another exercise, but take your time. If you cannot finish by next week, like I said, as long as you submit, for me it's fine. It's just that it would actually pile up, because there will be after this there will be a project, right? Project 1. So if you can't finish, then it would overlap with project 1. Right. So for this exercise, this is the final exercise, the last exercise before you proceed with the project. Okay. So for exercise 3, create 5 designs or patterns using the given rules below. Okay. Using scale factor 0.7. Right. If you use manual drawing, it doesn't have to be very accurate, so you can just sketch. As long as it looks like that, it is fine. Okay, but what you need to bear in mind is basically you need to understand where the new object would be connected to the original object or to the initial object, right? So I give you an example. Example of design. You may use this in your own design, so it doesn't matter. Okay, let's say this is the original. I think I add another sheet. Okay, so example is this is the initial shape, right? So remember the symmetry group, okay, because this is a box, a perfect box. So basically all the sizes are similar, right? The surfaces are similar. So you have 1, 2, 3, 4, 5, 6. You have 6 similar surfaces. So meaning that you can look at it from different angle, many different angle. Okay, from there, like this, and like this. Or you can look at it upside down. Look at it from this way. So many angles. I believe like perhaps maybe 24 angles. Okay. You have 24 different angles that you can look at the object. Right. Okay, so you should start with the bigger one, right? Because the rules basically scales down the additional object. So you should start with the bigger one. So when you apply the rule, let's say going back, let's say here lah, right? If the surface is here, then that's where you need to add the object. So if you look at it from here, so you add the object here, smaller in size, smaller by 0.7. And then if you look at it from this angle, again the same, the original shape, the initial shape, you look at it from different angle, you apply the rules, and you're going to add the object here. Right? You look at it from this angle, you can apply the rule, you can add the object there. Okay, and then you can apply to each subsequent shape. So here you apply here, basically you're going to add new object here. So keep applying the rules at the same, it becomes smaller and smaller, something like that. And here also the same. If you apply it, keep applying at the same side, it becomes smaller and smaller, right? But as I mentioned, you need to have some control. So if you look at it, the original object, you look at it from here, you add object here. Something like that. Okay. You should have some control on where you want to apply you're going to apply the rules. So maybe you control the first design, for example. Okay, so you want to apply the rules to only to this side and this side, or perhaps all the four sides. But A is upright, so in all the design A is upright. Okay, so that's the first control, and then even the subsequent shape also same position. Okay, here when you apply, you get something like that. Okay, and then for the second design, maybe you want to alternate. First, you look at it here. The surface here, the surface like this. The surface here like this, then this surface like this. Then you will get different result, right? And then for each smaller object also same. So you apply to the different angle, something like that. All right. Okay. So any question? If there's no question, then
no.
yeah. Maybe we can discuss if you want to, if you still don't understand about the exercises, so maybe we can discuss here. All right, Melissa, if you still have any question that maybe you still don't understand about the exercise, maybe I can show you here so that everyone can listen also.
Yes, can also.
So any question?
So would you update the slide later?
Yeah,
We'll
update.
Okay.
Yeah, I will update the slide.
I
Have you checked the times, or can you access times?
I still cannot access.
If not,
Mm.
if not, it's okay. Then I just post it here in this
Okay.
in Teams.
So I still
Yeah.
not understand the comment you give for my exercise this morning. Yeah, because
Yeah, which one?
yeah, the exercise 3.
Exercise 3, yeah. Wait, let
Yeah.
me open. Can you see it?
Yes. Yeah, the number 2. The answer number 2.
This one.
Yes, yes.
Is it?
I'm not sure why it's become the center have triangle there as you draw object.
Okay, wait.
How it's become the triangle? Is that
Yeah.
the rule number 2?
Yes, rule number 2.
Oh, okay.
Because okay, so basically here, right, when you create the design, first you apply rule number 2. You started with rule number 2, right?
Yes.
Become like that. Okay, but then how did you get this? How did you get this one? Because from here I can see that you basically you shifted the somehow you shifted the object like that, right?
Yeah. So,
which is not mirror, right? So that's why I said so you cannot simply mirror the object. So basically each you need to apply the rule one by one. So let's say first you apply rule number 2, and then so how it becomes like this, like this. Basically I apply again the rule to this side. So you just imagine this is the orientation, A orientation. The orientation is like this. Okay. So if A is like that, then you add like this. But here first, this is A. Okay, first A is like this, right? So that's how you got this, no? Right? And then for this triangle, I look at it from this angle. From this angle.
Okay.
So that's how I get this. And then I look at it from this angle. That's how I add this triangle.
Okay.
Then only you continue. So after you have this, then you can apply rule number 1. So you can you can add this triangle at the bottom there. Right?
Meaning we only can rotate the shape instead of mirror the object.
Whatever you do, the movement, the transformation should be based on the rules. So if there is no rules about mirroring the object, then you cannot do it.
Okay.
Unless if you have, let's say you have rule number 3. You have rule number 3. You mirror like that. So you have this object, and then you want to mirror like that. Then that's fine. So all the movement, all the transformation should be based on the rule that you put here. So you cannot simply mirror. So that's why basically all the designs here, I mean, it was wrong because of the mirror, right? Like here, so basically, but instead of mirroring the object, you can still get more or less the same design, but you only miss that part, the middle part there. So instead of mirroring the object, you should apply rule number 2, and then from rule number 2, you get to the other. So it becomes like this. but with the one in the middle, then it's correct.
Mm.
But because now the middle part is missing, so that's why you just simply mirror. But this side is
Okay.
correct lah. So this side is fine. Okay.
Okay.
In this case, this part is already right, but suddenly because you mirror along this line, right? You mirror
Yes.
to the
Yeah.
side. That's why it's wrong. Okay. But if let's say you apply rule number 2, shape there, and maybe then only you move to the you apply another rules, then that's fine.
Okay.
Okay. Maybe it's a bit difficult to understand lah at first, but I think after a few times we get it. Hopefully you get it.
Okay.
Okay, Aisha, any question?
No, sir, not for now. I think if I have any questions, I'll message you.
Okay, all right.
Yeah.
Yeah, Melissa, are you still? Do you have any question? Any more
I
question?
think I will try to redo the shape that I mistake. Then I only know maybe
Alright.
some, yeah, correct.
Okay, all right. So if there's nothing else, I think that's all for today. Right. So if you can submit next week, that will be better. If not, then just let me know if you cannot submit. All right. So I'll see you next week. Okay.
Okay, sir. All right.
Okay. Okay. Bye.
Okay, thank you, sir.
Thank you.
Bye.
Bye.
All right.